The purpose of this video is to show how I used what I'm calling a mini-Lucidity while developing Disk Atlas, and to show how its features correspond to the real Lucidity program. So I'll start with a demo of the mini-Lucidity and end with a quick demo of similar features in the real Lucidity. Before we get into the debugger though, let me give a quick overview of Disk Atlas, which we're looking at now. It's an app for showing how disk space is allocated across files and folders. The white rectangles are folders and the darker colored ones are files. The program has some overlap with the file browser. If I click a folder, I can go inside and it'll change the current path shown at the top here. Now if I press D, it's going to bring up the mini-Lucidity debugger, which is showing two groups of variables, primitives at the top, lists at the bottom. So let's start with the simplest feature of the mini-Lucidity, which is to observe the changing state of primitive variables. Oh, I should also point out that if this were the actual Lucidity, we could also monitor tables, hash maps, trees, and graphs here. But yeah, so the simplest feature, we're going to watch this state variable change from default to tile detail when I clicked on that, back to default, and then if I rescan this location, it's going to change to loading, back to default. So this feature is not significantly different from the concept of watch points from traditional stepping debuggers, since we're just looking at primitives and since we can't navigate through time. But now let's look at some of the list variables we're monitoring. On the top we have this drive table with two elements. Each one corresponds to a mount point on a connected drive. And then we have backstack and forward stack, which are the data structures underlying the behavior of the back and forward navigation arrows at the top here. So let's try going through some locations and see what happens. So the backstack is getting has elements being added to it. Now I've gone into 3 locations and there are 3 elements. And if we use the back feature, we can see the elements move to the forward stack. And if we use the forward feature, we see the inverse operation happening just as we would expect. So now I want to show how scan queue, active scans, and post scan queue work. And in order to demonstrate that, I'm going to need to change the size filter on the right here. Once the size filter is smaller, Disk Atlas will need to rescan part of the file system to find more files and folders. Before I press the button though, I should point out that the mini-Lucidity can be paused, which is what the yellow border here indicates. If it were the real Lucidity, it wouldn't be necessary to pause since we could just move backward in time to observe the changes that took place, but since we don't have that feature here, we pause. And the timing is somewhat sensitive, but let's give it a shot. Okay, I was kind of late, but we can see there are a few elements in the scan queue, and each of these has a location on the file system that should be scanned next. We have one active scan and one element to the post scan queue, which contains some code that will get executed when the scan queue empties. Now let's take a look at Lucidity for comparison. So currently it's monitoring 3 variables. We have one tree, one list, and one hash map. And right now we're looking at the final state of these variables after a program run is completed. But unlike with Disk Atlas's mini-Lucidity, we can move back in time and inspect what happened. So we'll go back to the beginning here and play back these operations. And I'm going to turn up the speed because there's a lot of operations on the list during the bubble sort. And that works fine as an overview, but we can also focus on any single variable in the scene here and step through operations that were applied to it in detail. And in order to do that, I'm just going to be using the right and left arrow keys, which are just next and previous operations. So we can see in the case of the list here that its form and function is essentially the same as the lists visualized in Disk Atlas's mini-Lucidity, but the full Lucidity allows us to observe other things like elements moving from one place to another, like we see in the bubble sort. And similarly, we can see that on data with different structures like this tree here, where we can observe subtrees changing locations by stepping through these operations. And that's it. Thanks.